In this exercise, we're going to be building a task manager. And this isn't going to be a web app, this is going to be a command line task manager. And we're not doing it because I really expect you to go use this task manager. It's really basic, you're probably not going to want to use it, and there's a bunch of better ones out there anyway. The primary reason for building it is that I just want you to see what command line interfaces are and how easy it is to build them with Go. So a lot of times you hear about how Go is great for DevOps, or it's good for web development, or it's good, good for different things like that. But another thing it's really awesome for is building these command line interfaces that you're going to distribute to many different operating systems. And the reason for that is because with Go, you can very easily go build binaries for any different operating system, with different settings, different configurations, and then they don't have to go install Go to run it. All they have to do is download your binary. And this is very different from, Java, Ruby, Python, those things where Java requires the JVM. Ruby is going to require you to install Ruby, Python, same thing. And, if you want JavaScript, usually you have to install Node or something like that to get those packages to work. Well, with this, it's just download my binary, and it doesn't really matter, you can use it. And that's why you'll probably see that, there's every once in a while on like Reddit and different sites like that, you'll see people who are like, oh, I wrote this replacement for curl, or I wrote this replacement for some other command line tool. And they're doing it in Go because it's really easy to build these binaries and then distribute them for different OSs. So Go is really good for this. And you can actually see this with just the Go tool itself is a binary that you're running, and you see that they just build binaries for different operating systems. And when you install Go, a big chunk of that is just downloading the binary and putting it in the right place. After that, most of it pretty much just works for you. And that's because, it's just a binary. So, what we're going to be building. I want to at least show you what we're going to be building, and then after that, I'm not going to dive too much into the exercise details. If you want to code this on your own, I suggest reading the exercise details. You can see it on the Gophercises site or on the GitHub repo, the README there. I have a lot of useful links there, especially if you're going to be trying to do it very similar to how we do it in the videos. Links to different packages that are useful and different things you might want to check out. But in the meantime, I just want you to see what we're going to be building. Now it's going to be called Task, and I've already installed it on my computer after I built it. I'll reinstall it as we go, so that'll be fine. But when you type Task, it's going to show basically the help menu. So Task is a CLI task manager, and it shows you some commands and rough usage. Now a lot of this could be customized a little bit more. I did this as basic as possible the first pass through. So just remember that you could customize a lot of this, and a lot of this comes from I'm using a framework that is useful for building command line applications, and that's what gives me a lot of this. So if you want to do different things with this binary, the way you do it is you add a subcommand. So I have task add, and this is how you add a task to your task list. So I might have clean dishes. Then I can do task list and list all of my tasks that I have to do. And you'll see here that clean dishes, except I had a typo there, is the fourth one because I already had 3 other tasks. So all of this information about the tasks is being stored in a BoltDB database. It's in my home directory for my user on my computer. So even if I reboot my computer or something, it's still going to be there, and it'll keep those things persisted throughout reboots. So aside from adding and listing tasks, the third thing is just task do, which marks something as complete. And to do this, you just put a number. So I'm going to put number 1, record the Gophercises video, because that's what we're doing right now. And even though it's not technically done, I'm going to go ahead and mark it off. And then you can task list afterwards, and you'll see that it's gone. Now, there's a lot of things that could be improved about this. For instance, if I were to have typed task do 4 after I did task do 1, it wouldn't have worked because all these got reordered as soon as I deleted or as soon as I marked one as complete. You could do things to fix that. I just don't think it's worthwhile for what we're doing, and this should be good. Okay, so that's it for the intro. In the next video, we're going to go ahead and look at how to build the command line interface part. We're not going to do any database interactions or anything like that. We're just going to get this, this part here where we type in task and it shows us some text. We're going to focus on getting that working. After that, the next major part is setting up the database code. And then the third part is sort of putting it all together and, making sure we can install it and everything works. We're going to start by creating the command line interface, basically just a shell of it. It's not going to actually create tasks or do anything like that, but it's going to give us the commands that will at least print something out to the screen and make sure we have all that part where the user interacts with done, so that later whenever they come in or whenever we come in and we're writing the BoltDB stuff, we already have something to connect it to, so we don't really have to spend too much time there. So the basic way I've split this application up is first we'll build the command line shell, and then the next part is we're going to go ahead and write some database code, and then finally we'll put that all together and make it all work. So to build a command line library, I recommend using a third-party library for this. Now, there's a lot of things where I wouldn't recommend it. For instance, if you're building your first couple web applications, I would actually recommend building a lot of it from scratch, mostly because it's really good to understand how all the pieces work. But for something like a command line interface, the reason that I don't generally tend to do that, even when I'm just jumping into it, is that there's a lot of little details that are really annoying to get right. And usually not understanding them too much right off the get-go isn't as big of a deal, because you're not going to be building this really big thing that you need to customize a lot. For a command line application, generally you add a couple commands to it, they plug to other Go code, and you don't need to do too much customization for that sort of thing. That doesn't mean you can't go write it yourself. If you're writing a lot of command line applications and you want to learn that sort of thing, dive into it, experiment with it, and see if you can get it working. I encourage you to do that. But for the purpose of this exercise, we're going to be using a third-party library called Cobra. So it's in the task description here, and I'm going to open that. I also want to show you, before I go over Cobra, there are a lot of libraries for creating command line interfaces, and most of them are listed here on this awesome Go site. So when you look through it, you'll notice that there's a bunch of these standard CLI ones. All of these are going to do roughly what we're going to be doing with Cobra. Or they should do something along those lines, or maybe they're a little bit simpler, a little bit more features, but that's the type of application they're for. And then there's the advanced console UIs, and these are going to be a little bit different. Things like Termbox and TUIGO, these are designed to take over the entire terminal and to give you like a UI built in the terminal. So you can see here at the screenshot, you don't even have the command line prompt. Instead, it takes over the entire thing, and you can draw a little bit. You would use this if you're building maybe a chat application, or depending on what you're building, sometimes this sort of thing is cool. I think some of the things I've seen people build are like music players that integrate with Spotify or Google Music or one of those. Different tools like that are possible, but we're not going to be doing that here. I think this is overkill for what we're doing, especially because we just want a really simple task manager. And to do this, we're going to use Cobra, which I've brought up here. It's a package by SPF13, and I'm not going to sit here and tell you this is the best command line interface library. I honestly don't know. What I do know is that I've used this before, and I know it's going to cover all my needs. I know how it works for the most part. So for me, that is more important than necessarily getting the best command line interface. So I went ahead and just used this for this exercise because I've used it in the past. Now, as we look at this, there's a couple things you need to know about how Cobra works in order to use it effectively. And most of these you can sort of figure out as you go. They're not covered in too much detail here. They're covered here, so I shouldn't say that. They're just not necessarily the first thing you'll see. But once you figure out the basics of how it works, it's really easy to build things with it. So the first here in this getting started section is the app structure. So you'll see that they have your application, and then inside of there we have a main.go. It's on the same level as your application. And the primary reason for this, I believe, is that so whenever you go to go install or go build things, it's going to know that you should be using this app name. Whatever your folder name is here, it's going to use that as your application name. So this is nice because we've got our directory. This is the wrong thing. Here we go. We've got our directory. We've got this task directory. So when we install this, it will name the binary task, and that's what we want. So inside of that, we've got a main.go. And the purpose of this main.go is not to actually do a lot of heavy lifting. It's to set things up before the actual Cobra stuff kicks in. So we would do things like if we need to connect to our database, if we need to figure out the user's home directory, that sort of thing makes sense to do in this main.go. And then we have the command directory, CMD here. And inside of that, that's where we're actually going to put commands that Cobra is going to use. And there's not going to be any magic. It's not going to magically look for that directory and make it work. So you don't have to name it that. But it is kind of nice when people are, it's a pretty common thing that if you have commands in your application, usually you'll have a command directory that'll, that's where you'll sort of list a lot of these commands. So it's just following that, normal pattern where other developers will kind of know where to look for this sort of thing. And in here, every single command is going to have a separate .go file. You don't have to do that again. It's just a nicety, so when you go to look at somebody's code, if everybody's doing the same thing, it's kind of easy to figure out what's going on. So, going to our code, we're going to make the dir command, and then I'm going to open up a main.go file. This is not in the command directory. And I'm going to do package main, func main, and I'm just going to save this for now. Nothing is going on here at all. Now we're going to add them inside the command directory. We're going to create root.go, and this is going to be our root command. So when we just type in task, this is going to be the part that handles that. So we're going to name this package command, and then we need to define our root command. And it's going to be a cobra.command. And I'm going to go ahead back to the docs. If you look through here, you'll see that it talks about a root command here, but really all commands are going to look very similar to this. So we've got 4 fields here that are worth looking at now. And then if you want to dive deeper into this on your own, you can. So the first is use, and this is basically just the name of the command. So in our case, if it's the root command, it's whatever your binary is going to be named is generally a good name for this. So, and this is showing Hugo as an example, but for us, say we're going to name it task. So task, which is what we'd use here. Short and long are short and long descriptions of what this command does. And then run is the function that gets run whenever you run this command. And there is one caveat to that, and we're going to look at that here in a second. So paste this all in here, and I'm going to make this task, and we're going to say, we'll say task is a CLI task manager. I'm going to delete the long. We don't need a long description, so I'm just going to go ahead and delete it. You could put one if you want, but just for brevity, we're not going to really cover that in this video. We're just going to try to go through the rest of it. And then we've got this run command, and you can see here that it takes in a Cobra command and a list of args. And we're going to look at those two in a bit. But for now, the root command doesn't actually do anything in our code. We want our root command just to list all of our tasks, or sorry, just to list how the task application works. So we're actually just going to go ahead and delete that. And when you delete that in Cobra, it'll actually change the root command, so its default behavior, instead of running a command, is to show you the help text. And we'll see that here in a bit. Once we add some subcommands here, you'll start to see it. Okay, so I've saved this and it imported this Cobra package, which, if you haven't already, you'll need to go get it. So that's go get-u, github.com/spf13/Cobra. All right, so the next step is our main.go, which we have open. And what we're going to do here is go to that command package that we have. We're going to take the root command from it, and we're going to execute it. That's all we're going to do in main.go for now. So assuming that all worked, we should be able to go install, and then we should be able to just run task at this point. And you'll see it says task is a CLI task manager. It's not showing anything else just yet because we don't have any subcommands, we don't have anything else. But once we start adding those, we'll start to see those here. Let me look here. Okay, if go install doesn't work, it probably means you didn't set something quite up with go correctly, and that's fine. Or if say you're running inside of, whatever tools you're using, maybe you're running inside of Goland or something. You can do go run main.go, and this will work. But later when we start doing subcommands, you're gonna want like add, and that just looks kind of weird. So I definitely suggest instead doing things like go build, and then you'll see here that we get this task binary. So you can actually do /task, which will run this local one instead of looking for the one on my path. But I'm actually going to just use go install in this task throughout the rest of this, so that whenever you do go install, it actually makes it so it doesn't matter where you are, you can just run that binary, which is what I really like about it. It allows us to run it anywhere on our computer. Okay, so the next step is adding more commands, and we're going to start by doing this manually, and then after we've done it manually, I'm going to show you how you can use some of the features of Cobra to automate this. And specifically, Cobra is a command line interface. So when you install it, whenever we go get it, like you saw me do before, it installed this application that we can actually run from our terminal, and it'll help us generate Cobra applications. So the main commands here are add, help, and init. And add is going to allow us to generate the code to add a new command to an existing Cobra application. Init is going to initialize the application. And this is another reason why structuring your code the same way they expect is very nice, because these generators all start to work a little bit better for you then. Okay, so we're going to create the command. We'll do add.go. And this is the command to add something to our task list. And I'm just going to name it add.go. We'll make the package cmd. And then we need to declare the variable that is the command. So we're going to do Cobra.command. And just like before, we're going to come back here to the docs, copy this, paste it in. And then we're going to name the use. In this case, since it's not our root command, it's meant to be a subcommand. The use is actually whatever that subcommand you want it to be. And then for the short description, we'll put adds a task to your task list. And then for the run part, for now, let's just go ahead and just print out add called. That way we know that this command was called. So let's go ahead and test this, and I'm going to warn you this is not going to work, but that's intentional. So if I do task add, you'll see that nothing really happens. If I do task, it's not showing us. If I put -- help, nothing seems to be going on. So what's happening here is that while we've declared this add command, as I said before, Cobra doesn't do anything magical. It doesn't know about this command yet. It doesn't have it, linked into our application. So to do this, we need an init function. And in this, we're going to call root command.add_command, and we're going to add the add command that we just created. Now that we've added the init function, I want to take a moment just to talk about what an init function is so you understand what's going on here. So in Go, you have the main function, and if it's in your main package, at this point you've seen that that's the first function that gets run. Your application runs that, and that's how it kicks off everything else you're doing. Init is a function that can be run before the main function, and you can have many of them. So for instance, we could have an init in add.go, we could put another one in root.go. You can have many different init functions, and they'll all get run before the main.go or the main function in your main package gets run. And the idea for these is that they can set up things, different things that might need set up for some reason or another. You can actually read a little bit more about this. If you just search init Golang, you should see the effective Go doc here, and there's a init function section. And this will cover this in a little bit. It's relatively brief. You can read about it. It's something to be familiar with, but I will say that generally speaking, it's not that you shouldn't use it. It's just that using it too much can lead to people using things like package level variables and stuff like that when they shouldn't be. So just be aware that it might not always be the best solution for what you're doing. Maybe it makes more sense to define a type and to provide a way to initialize that type and set it up so that you can have multiple instances of it. Whereas the init function, generally, because nothing else is run yet, has to work on package level variables and package level code, which can sometimes be bad. All right, so in this case, we're doing it. I just got done saying package level variables and stuff like that can be bad. In this case, we're doing it because this is such a simple application, and the way we're setting everything up, I think it's fine to do it this way. And as I said before, the command line interface shell, like this part here that just sort of kicks off the commands, is so simple that I don't think it's something to get overly worked up over. Okay, so we've got this command working. Now I want to show you what happens now that we have it. So I'm going to go install, and then I'm going to just call task. And you'll see here that now that we have a subcommand, we get a lot more output from the task command. And most notably, we've got the available command section, and this lists the add command that we just created and a help command. So the help command is something that's always there with Cobra. It allows you to do things like task help add, and this will give you the help text for the add command. You can also do task add -- help. So this is another cool thing about using a library for building your command line interface, is that you get these niceties right out of the box without doing anything yourself. So this is, as you can see, it's telling us the description we wrote, adds a task to your task list. And if we do task add, it will actually run the task add command, which just prints out add called. So that's what's going on here. And that's why we actually didn't define a run function for our just task command, is when we call task, we just wanted to print out this list of what commands are available. So now that we've seen how to register new commands to our Cobra application, and we've seen how all of this works. What I want to do next is look at how to use the Cobra command line interface, because it does actually come with the CLI, using that to generate our command line interfaces. So we're going to go ahead and I'm just going to type in Cobra, because when we installed Cobra, it added this command line interface for us. And it's got 3 commands, add, help, and init. Add is going to allow us to add new actions to our application, which we'll do here in a minute. But first, I just want you to see what the init gives you. So you can see if you were starting a brand new application, you could use init to set up the directory for you and set up a lot of stuff. So we're going to do this. You can't do this on a directory that has stuff, code in it. So we're just going to go ahead and do Cobra init github.com/gophercises/task call it auto. So if I cd into this and open it up, you'll see that this is going to be a little bit different than what we have. So we've got a main.go, and it's very similar, but the main difference here is it just calls an execute function inside of the command package instead of calling root command.execute. And then inside of the command package, there's a little bit more going on. So what's happening here is it's setting up a couple flags. It's using the user's home directory to read a config file, I believe. And the execute function is still eventually calling root command.execute, but it's checking for errors. And if there is an error, it's going to print it out, then os.exit with a one status code, which is a status code that means something went wrong. There was an error with our application. So it's doing this os.exit part because, generally speaking, if your application shuts down with a bad status code, there are times where this is useful. When you're using command line applications, it can be useful. So it's kind of nice to have there. I think we'll use it a little bit in our code, but for now, I'm not going to get too worried about that. I just want to get this mostly working. But yeah, so you can see this is different. I just wanted you to see what it looks like. We aren't going to be using this, but if you wanted to in the future, you could. You could just take their auto-generated root command and then build on top of that. So deleting that, what we're going to be doing is first deleting that auto-generated one, and then going to our task directory again. And what we're going to do is the Cobra add command. So the way you use this is Cobra add and then a command name. Well, it looks like up here's where it has it. So if you do Cobra add server, it'll end up creating a command/server.go. So that's the important part here, is that we want to be able to just create new commands by typing Cobra add, and say we're doing the list command. We can type Cobra add list. We can also do Cobra add do, and this will create the do.go. Okay, so we've got these 2 new commands. Let's go ahead and look and see what they look like. First, we've got this big copyright section. I don't really need that for what we're doing, so I'm going to go ahead and delete it. And we don't really need this comment, so I'll delete it. I think that's fine. We can change the short description, and all of this looks very similar to code we've written. So you can see that it's got a run function. It's just calling list called like we did as well. We don't need this long description. The short one, I'm going to go ahead and put list all of your tasks. And then if you look down here, you'll see there's an init function here that does the same thing we were doing. It takes the root command, it adds this list command to it so that it knows about it. So again, this is one of those cases where having your code structured the way that Cobra expects you to have it can be useful, because it can allow these generation tools to really, do some lifting for you and just generate the boilerplate code for you. We don't need these comments. That comment will sort of describe some of the stuff you can do there. Some of the things I've talked about, different flag customizations or different things like that. Again, we're not going to worry about that for now. Okay, so we've got this list command is pretty much set up. Let's get the do command, do the exact same thing. Let's come in here and delete the long description, and then just change this to marks a task as complete. And we're not even going to put usage examples here. Generally, you'd want to, but I'm not going to for now. I'm just going to let this be. And lastly, we'll delete those comments. All right, so if all went well, we should be able to do task and see the add, do, and list commands. So if we do task list and task add, all 3 of these are calling the functions that we set up. So we have the shell done at this point. What I want to do next is look at how to interact with the arguments inside of those commands, because later, once we have our database code set up, we're going to need to know when we call task add clean dishes, we want to know how to get that clean dishes part out. And I think it's important to look at how that works now, because later we're going to be doing so much other stuff that we'll kind of forget about the Cobra stuff at that point. In order to see how to get that extra text from the user, what we're going to do is we're going to go to the add command, and we're going to just go ahead and write the code here and experiment a bit to see how we get that out. What we want to be here is we want to be able to type task add something like record the video, if I could type. And we want this to go ahead and grab this text, record the video. So right now it's not doing that clearly. We don't have anything going on here except for putting add called. So we want to figure out how to get that extra text. Well, we know that whenever we call something on the command line, generally speaking, those extra bits are considered arguments. So this arg slice is the first place I would start looking. And to do this, I think it's important to not just print out the args, but to instead iterate over them so you can tell exactly what each entry is, because it's hard to sort of tell if it's one word with 3 spaces if we just print out args, or if it's three different strings in our slice. So we're going to do for I arg and the range of args. We'll do I, a colon, and then the arg. And then if we run this, if we go install, and then we run it, you'll see that it's typing 3 different entries here, or it's printing out 3 different entries. So it looks like whenever we do this, each different word, the space separated words, are different entries in that arg slice. So let's go ahead and see, all right, what happens if we put quotes around this? All right, well, when you do quotes, it looks like it's all just one big arg. Both of those are fairly normal from what I'd expect, having used different command line applications and things like that. Usually all the different commands or arguments are space separated. So that seems to make sense. What we're going to do now is we're going to look at, all right, knowing that's the case, can we make both of those use cases work for our code? Well, the easiest way to do that, in my opinion, is the strings.join, which will take in a slice and will allow you to merge all the elements of that slice together with whatever character you want. So we're going to merge everything in args, and as it merges them, it's going to put a space in between them all. So we'll do task is equal to this, and then we'll print out added, I actually want print f, not print line. Added %s to your task list. And we'll put a new line at the end. And then we need to pass in an argument here to get filled in with this %s part. So I'll put the task here. Go ahead and save that, and then let's go install. And let's try first just the one with quotes, and you'll see that it has record the video. Obviously there's a typo in there, but that's fine. And then we can see the other version with record video number 2. And again, this is working correctly. So it looks like that code is doing what we want. And the next thing we're going to do is the task do command. So we know when we call task.do, we want to be able to provide it with a number. So we don't want to have to type in task do record the video, or it doesn't really make sense. It doesn't read as well. So what we'd probably want to do is something like task do 1, and this will mark off the first item in our task list. Also, it might make sense to do maybe task 1, 2, 3. Maybe you want to be able to provide 3 different tasks. So we're going to go ahead and add support for that. Not with the database, obviously, but we're going to go ahead and take the do command here, and we're going to parse the arguments so that we get those numbers out of it. So to do this, we need to go through all of the args, and we need to turn them into integers. Right now, they're going to start off as strings, and we want to convert them into ints. So first, we'll say var IDs is going to be an integer slice. And I'm doing an integer slice because, as you saw in this very last example, I want to be able to do multiple IDs all at once, or multiple numbers all at once. And then once we do the IDs, we're going to iterate for, I don't think we need the index. I think we just need for the arg and the range of args. And inside of here, what we want to do is take the arg that we have, convert it to an integer, and if it's a valid integer, we're going to add it to our IDs list. So we're going to say id air : equals string conversion dot a to I, and pass in arg. If the air is not equal to nil, then we want to go ahead and print something out like failed to parse the arg. We don't even need a percent. We can just put arg here. Otherwise, we're going to IDs equals append IDs with the new ID. And then at the very end, let's just go ahead and print out these IDs. So assuming that all worked, you can see here that we've got the 1, 2, and 3 integers added to our slice. And if we were to do task do 1, John 2, you can see here that it says failed to parse the argument John, because that's not an integer. All right, so before we move on, I don't know if I've talked about this in other videos, but this A2I part, that's usually something that throws people off. It doesn't make sense to them, especially because they're looking for a function named parseInt or something like that. So what is going on? Well, to answer this, let's look at the string conversion package. This is a package with a bunch of functions that help you take strings and convert them into other data types or do different things like that. And there is a parseInt function. You can actually see it here. And if we go to the index and look for parseInt, we can go to it and you'll see that it looks pretty confusing. So it takes in a string and then it needs a base, a bit size, and it returns an int64 or an error, or maybe both. Hard to say. So looking at it, you're probably like, that seems pretty confusing. Why do I need all of this stuff? Well, parseInt is more generic. It's designed to be something that you can parse hex or different things like that if you want. So in short, it's something that's really supposed to be there in a more generic form so you can parse different formats of integers and do that. What we're using is A2I, which is up here. Let me click it. This stands for ASCII to integer, I believe. And I think it stems from C, but maybe it stems from something before that. I'm not really sure. But basically, it is meant to take an ASCII string and convert it into an integer. And this automatically assumes that you're using a base of 10. The bits part, it's putting 0 here, which I think is letting it figure out on its own. I'm not really sure. But basically, it's using parseInt behind the scenes, but it's just kind of a nice wrapper that does the smart defaults that most people probably want when they're dealing with integers. So that's what's going on here, and that's why we're using it. Okay, so we've got all of this. We've got our IDs. For list, we don't need any data from the args. So at this point, we're actually ready to move on to looking at the BoltDB stuff. This is the shell. It's all there, and I have a branch already checked out, so I'll commit this off the video. But that should be pretty much all the stuff we need to build out the shell. The rest of this is going to be building the BoltDB and then connecting the BoltDB code with this code so that it'll actually create and mark tasks as complete and things like that. The next thing we need to do is write out our BoltDB stuff. So we need to write out the database layer, and then we're going to connect that to our command line interface so that we can start storing these tasks as users create them. And we could do something simpler like store it on a text file, do different things like that. The primary reason we're not doing that is that I just wanted to give you a chance to see how BoltDB works, but also just because, having to deal with a text file or something like that might be kind of annoying depending on, whether a task has new line characters in it or something like that. So we're just going to go ahead and just store them into a database and be done with it. So I've already got, I've got a link to it here in the description. I've already opened this up. I'm going to give you a quick rundown of what Bolt is, and then we'll look at how to connect to a Bolt database in our code, how to start reading and writing from it, that sort of thing. But I do want to mention that if you plan on using Bolt, I highly recommend reading over the GitHub page here, especially the Getting Started section and all the stuff that talks about, how Bolt works, different stuff like that. It's definitely worth understanding it if you plan on using it in a lot of different applications. But if you don't plan on using it, if you're just watching the videos trying to follow along, that's fine. You don't have to go read this all right away. It's just something I would recommend doing before you use this really heavily in a really sensitive environment or anything like that. Okay, so what is Bolt? Bolt is a pure Go key value store. What does that mean? So the fact that it's pure Go is important because it means that you don't need any third-party libraries installed. You don't need any other dependencies. So if you were using, say, MySQL or Postgres instead, The downside to this is that whatever computer you run your application on needs to have Postgres or MySQL installed, so you can have a server start up to run the database and you can connect to it and do that sort of thing. Because this is a pure Go thing, all of the database code and everything like that is handled within our Go code. So all we really need is a single file on the file system that serves as our database file. And that's what makes this really good for a command line interface, as well as a bunch of other things. But it makes it really good for our command line interface because if we build this binary, we don't have to ask them to install other stuff. They can just use the binary and it'll be fine. So the key value part, we'll get into that in a second. But one thing I do want to mention is that this package is very simple. And I don't mean that in the sense that there's only like 3 functions or something like that. Or I shouldn't even say this package, I should say this database is fairly simple, especially when you compare it to things like MySQL and Postgres. Bolt is a much, much simpler database. And that's a good thing in some ways. It really depends on your situation, but for our use case, it can be very good because it means that once you start to learn the different parts of it, there's really not that much to learn. Whereas, Postgres, MySQL, you'll see people that have been using it for years and still don't quite understand every little minor, edge case or corner case, and they still have to research things at times. Usually with Bolt, at least in my experience, once you understand the core of how it works, you don't run into too many crazy edge cases or anything like that. Okay, so how does this work? I don't know if it's in here much, but the basic idea is that we've got buckets, and these are kind of like tables in a SQL database. There are things that sort of define what type of data is going to be in it. So for instance, you might have a tasks bucket, you might have a users bucket. You can it depends on how you're designing your application, but these buckets are going to be things that contain key value pairs. And every bucket will have a completely unique set of key value pairs. So like you could have the same key in 3 different buckets and it can be mapped to different values in each of those buckets. The key value pairs are pretty much what they sound like. The key is going to be a byte slice or a byte array, however you want to think of it. I think we're using byte slices in our code. So it's just going to be a byte slice that represents, what this is the key for the object, and the value is also going to be a byte slice. So that's important to keep in mind because it means we can't take random structures and that sort of thing and just slap it into Bolt. We have to somehow encode it into a string or byte slice and then put that into the database. So what is it good for then? One of the great use cases for this is a high read, low write scenario. So if you're writing an application that has a lot of reads, but not a ton of concurrent writes, then this works very well. And for our application, we're going to be low read, low write. We don't really have any performance needs for a command line interface because it's meant to be used by a person, and one person on a computer generally is not going to hit anything near the limits of what this database can do. So the reason why I say it's good for high reads, low write is because in Bolt you can do they call it a read-write transaction, so you can both read and write in it. You can do one read-write transaction at any given time. You can only have one going on at the same time though. And whenever you do reads, you can have as many reads as you want going on at the same time. So this means that, say one user's updating something in the database, nobody else can read or write to the database during that. But a bunch of people can be reading all at the same time. So, if you have a website that just gets a lot of reads, this works very well. An example of this is Gophercises, this course. For the most part, I don't write a ton of stuff to the database. When you sign up, there's a little bit that gets written there, basically just to set up the account. And I have some entries in there for, which exercises there are, where the videos are stored, that sort of thing. But aside from that, there's not a lot of writes going on. And, there's well over 6,000 users at this point. So, you can see that it's handling, which that's not a huge number, but you can see that it's handling that sort of load fine. We don't have any issues. And, that's the type of thing that this is going to be good for, those low write, high read scenarios. And I think they actually have some examples in the docs, where they talk about companies like Shopify and Heroku are using Bolt back services. So there are big companies using this for production systems that, are actually getting some pretty heavy traffic. So coming back down here, I think I want to go here. So the first thing is that we just want to go get this. I'm actually going to wait on that for a second. But Again, if you want to learn about this, I definitely recommend reading this stuff and getting an idea of what transactions are, what a read-write transaction is, because as I go through this video, I'm not going to stop and explain it too much. That's something that I'm going to let you do on your own. Okay, so let's go ahead and jump to our code. And in here, we're going to look at how do I connect to our database, and that's pretty much all we're going to cover right away. And then we're going to jump into actually storing these key value pairs in buckets, which is going to involve creating a bucket and that sort of stuff. So we need someplace to put this code. I'm going to go ahead and put this inside of a DB directory. And I'm going to warn you now, I'm going to go ahead and write this code in a way that I generally wouldn't for web applications and that sort of thing, but I think is going to be fine for what we're doing here. So by that I mean I'm going to use package level variables. I'm going to just create functions that are package level that use those package level variables to connect to the database and do things like that. I'm doing this because I think it makes the most sense for what we're going to be doing with this application. It's going to be very, very simple. I don't think it's worth going through the effort of building a struct, initializing it, and setting it all up. We could do it. It wouldn't actually hurt us to do it, but it wouldn't even take that much more time. But I just think for now, this is fine. Okay, so I made the DB directory. I'm going to add them DB. We'll just call this main.go. I'm actually going to go ahead and just call this package main. We're eventually going to change the name of the package to DB, and we're going to probably rename this file. But for now, I just want to build something that connects to a database. So we're not going to do imports, so I'll just let that happen automatically. So I need this func main, and in it we want to connect to a database. Over here, if we look at the code, you'll see that there's a couple examples that show this. So we can just go ahead and grab the code. The difference between this version and this version is very simple. Basically, when you go to open a database, there's a chance it might time out. If it does time out, there's a chance that it might be used. Whenever you have a Bolt database file, only one process can have it open at a time. It gets locked otherwise. And this is to make sure that you don't have any two different writers from two different processes going on at the same time, which would be a big issue. So in doing this, it's possible to try to open a file that's already being used or that's already locked, and your program will just hang there pretty much forever. So one way to handle this is to put a timeout, and that's shown here. So we're going to go ahead and put the timeout. We'll say if the error is not equal to nil, we'll just panic with the error. I think that's fine. And then we'll defer db.close. So if we go ahead and run this, well, you'll see that this mydb file was created. So it looks like it made the connection, everything was fine. Nothing was printed, so it's really kind of hard to say. It should be fine though. I mean, based on what I've seen, we would have seen an error if it, would have panicked if there was an error, so we should be okay. Now that we have a connection open with our database, the next thing we want to do is talk about how data is stored in it and look at how we're going to be doing that. So before we really jump into actually writing code that reads and writes data, I do want to just go over some of the things that are going to be present in Bolt so that we know about them. Specifically, so the first thing, keys are byte slices. Same with values. They're going to be byte slices. So you're usually used to storing keys or IDs in databases as an integer. There are ways to make that work. We'll see that here in a bit when we go to write our code. We'll write a function that takes an integer and turns it into a byte slice so we can store integer IDs into our database as the key. And then we'll write another function that will take that byte slice and turn it back into an integer so that whenever we're turning it to our command application or our tasks application, the CLI, it doesn't have to think about byte slices. Another thing to mention is that Bolt has a lot of useful tools for generating things like the ID. So we don't want to have to figure out, all right, what IDs are used, which ones aren't used, what's the next one we should use. Bolt has some stuff built in that will make it easier for us to do this. So specifically, it has an auto-incrementing ID that's already, I think it's an unsigned integer or an unsigned int64, something like that. So it's going to work for our use case. It also has a way to increment over every single key in a bucket. So let's say we have a tasks bucket and we're storing things in there. It has a way to, go over every single key and value inside of the bucket. So we won't have to try to figure out which keys are being used in our database. I think I mentioned this earlier, but as we go to store the data, it does need to be in a byte slice. So that means we can't just take a struct and throw it in there. We don't just want to throw random binary data in there. We need to encode it in some sort of format that we can consistently decode. So if you had a really big structure, you might want to JSON encode it. Or you might want to think, all right, if I need 3 different fields and I'm going to be editing each of these fields separately, maybe I need to think of some other way to do this. Maybe that is 3 different buckets, 3 different buckets all with the same key for the same resource. It really depends on what you're doing and what makes the most sense. So I can't tell you how to design your stuff. All I can say is that there are ways to do it. You just need to come up with what makes the most sense. So I should also mention another one. Another option would be like nested buckets, that sort of thing. That is possible. So you can have a bucket, and then inside of the bucket you can have a key, and its value can be another bucket. And then inside of that bucket you can have a bunch of keys. So let's say you had an object like type user struct, and then we had name string and email string. And let's say we had ID int. So let's say we had something like this. One of the things you could do is you could have your first bucket. So it could be user bucket, and this could have a key. Let's say we did key value. It could have a key of whatever the ID is. So this would be some ID 123, and then its value would be some bucket. And then inside of some bucket, we might have keys and values as well. And in here, we might store something like name is the key and the value is John Calhoun. And we might have an email, and this is john@calhoun.io. So you could do something like this where every entry you store an ID, or the key is, it's pointing to some bucket, and inside of that bucket we've got all the different attributes of that, that resource. So that is one way you can sort of get around this. I'm not actually super familiar with what the performance of that would be. Most of the things I've done have been either very simple, or I have used, let me go ahead and look it up. There is a package called Storm, and I've used it for a couple different things where I have an interface, a structure like this, and I want to have it encoded into BoltDB stuff. This is a really simple way to sort of set that up and make it work. It's kind of like Gorm for SQL databases, except it's meant for Bolt databases. So this is another option if you have more advanced structure and you just want to let this sort of handle that for you. I haven't actually looked to see how they do it, but you can even look at this source code to sort of get ideas. Okay, so I think that's everything that we need to cover. We've covered nested buckets. We've covered just different parts of the, how you store data and that sort of thing. We're going to go ahead and start creating a database package, and in it we're going to look at how to create a bucket, and then once we've created a bucket, we're going to look at how to start adding things to that bucket. So I'm going to go ahead and I'm actually going to delete this code. We're going to, I'll just rename the file. So rename this, and we're going to name it tasks.go. I think that's fine. And this is going to be a file that contains all of our source code about the tasks bucket in our Bolt database. So we're going to name the package DB. I'm going to go ahead and just delete all this for now. And we're going to start with this is going to be a variable. We're going to start with a variable, which is going to be task bucket, and it's going to equal byte slice of tasks. So this is just a string. It's basically a string that's meant to represent the name of the bucket that we're going to store our tasks in. I'm not using a constant, and I'm instead using a byte slice here because when you provide this value to Bolt, it expects it to be a byte slice, and I find it's easier to just go ahead and store it that way so that we can use it. I don't know of any specific ramifications for that, but if you wanted, you could just store it as a constant and then cast it to a byte slice every time you use it, or convert it, not cast. So then we're also going to want to store a BoltDB. And as I said before, this is going to be a package level variable. We're just going to keep it here so that we can use it for all of our stuff. Next, we need to define a task. This is going to be a structure, and this is actually going to be very simple. I'm going to keep it as a structure just because you might change yours over time. But for now, this is just going to be a key, which is an integer, and a value, which is a string. And this is roughly all a task is. It's got a key, which is going to be an, some sort of int and a value. And then next, we want some way to initialize our database. So we've got this DB variable up here, but it's going to be nil. So we need some way to set it up. Well, we could do an init function, something like this, and have this figure out where we're going to have the database and look it up from there. But I think it makes more sense here to let somebody pass in a database path, and then we'll go ahead and open that up and set everything up that way. So what I think it makes the most sense here is to do init, and this will return an error if there is one. And I should mention that because this is a capital I, it's not the same as the other init. This will not get run automatically. This is just an exported function that we need to actually call. And we're going to do var error, and then we're going to do db comma error equals bolt.open. We want the db path, and we'll do and bolt.options. This is the same code that we saw before. I want seconds. Is it second? I think it's just second singular. Okay, so I'm going to stop here for a second. This part here, the bolt.open, is the same exact thing we did before. That's why I'm kind of just breezing through it. The error here, it's probably looking a little weird here that I declared the error and didn't just do this, the colon equals. The reason I didn't do that is because if you do that, this db will be a local function scoped variable. I want it to be this package level one. In order for that to work, I can't be declaring any new variables when I do this, which means I need to go ahead and declare the error ahead of time. So that's why you're seeing these on two different lines. Then I want to do if the error is not equal to nil, return error. Otherwise, we're going to return db.update. And this is where we're going to go ahead and I'm going to hit enter. This is where we're going to go ahead and set up our bucket, make sure it's created. And to do this, we're going to use a function that's create bucket if not exists, which is basically going to do exactly what it says. If the bucket is there, it'll create it. So inside of here, we're going to name this tx instead of bolt dot, or instead of arg1 or whatever that was. And we're going to do underscore comma error colon equals tx.create bucket if not exist. And we're going to name this task bucket, whatever that bucket name is. And then finally, we're going to return that error. And we're doing this because this function that's you pass a closure into the db.update, or you don't have to be, it doesn't have to be a closure. It's just a function that matches this definition. So it needs to take in a bolt transaction, and then it needs to return an error. So we're going to go ahead and return any errors that occur while creating the bucket. This first part here, I believe, if I recall correctly, is the actual bucket after it's created, but we're not doing anything with it. So I'm putting it as an underscore because we aren't going to use that variable. And I think that's, oh, so I also mentioned, so we return error here, and then up here we're returning db.update. So what's going on? So db.update, it takes in this function. So this right here function could be something like this, and then this could just take in the function. So this probably makes it look less weird. We're calling this update function, which can return an error if there's an error. So if this function here returns an error, db.update will end up returning an error as well. So I'm going to go ahead and put this back inside of here. This is a fairly common pattern to have these closures right inside of a function call like this. So if you haven't ever seen it before, you're probably going to need to get used to it. It's pretty common in Go stuff from what I've seen. Okay, I think that's everything for this file for right now. It will connect to the database just like we were doing before, but it'll go ahead and create a bucket for us to store our tasks in. We're going to want to run this from our main.go, and there's two ways we could do this. We could, one, we could just use the whatever directory we're in, or two, we could go ahead and find the user's home directory and build that. I think it makes more sense to find the user's home directory right now. So I'm going to look up homedir Golang. This is a package that is very, very simple. If you look at the source code here, it's 137 lines, so very small. You could try to write this yourself, but this is one of those cases where I think it's better to just go ahead and grab the package and use it so that you don't have to worry about getting this right. So what it's doing is, in Mac OS, for instance, a user's home directory, let's see if this works, is going to be something like /user/username. In Linux, it could be different. It depends. I think it normally is, but I'm not sure. It's been a while, and I'm tired today. But in Windows is the big thing where it's going to be very different. And this is especially, concerning depending on how the computer was set up, what the drive letter is. There's all sorts of things that could change this. So rather than trying to, figure it out for every different operating system, the entire goal of this package is to just figure out the user's home directory and then give it to you in a way that you can use it easily. So we're going to be storing our database in the user's home directory because we don't want to use wherever they currently are, because that would mean that if they move to a different folder, they would get a different set of tasks. We don't want that. We want them to have the same set of tasks no matter where they are, so we're going to go ahead and use the home directory. So we're going to go get -u, this github.com/mitchellh/gohomedir. So once we have that, we can just do homedir.dir, and what does this return? Returns a string and an error. So you can check this error here if you want. I'm just going to ignore it for the time being. I've never seen this pop up an error, and if it does, our binary is just not going to work anyway, so it should be roughly the same effect, I think. So once we have this, we need to join this string that we have. So we want to do filepath.join. We're going to join home with, we'll do tasks.db. So this will go ahead and create a database path. And then we're finally going to do db.init dbpath. And we're going to say error : equals, if error is not equal to nil, panic with the error. So assuming that all worked, we've imported these packages. It should be initializing, opening up the database or creating it if it's not there, and creating if the tasks bucket if it's not present. We can test this. It just ran. It doesn't really say anything, so I'm going to assume it's working. We can go ahead and put something like that. I want this. And you'll see up here it says DB stuff worked. So it looks like that's working fine. And finally, before we move on, generally speaking, we don't want to panic everywhere like we are here. So what I'm going to do is change it just a little bit. And I say that just because the panics aren't going to be useful for users. So maybe we just want to, well, I guess they're not terrible, but what I'm going to do is just write a must function, which is going to be a simple little helper for the time being. And we're only going to use it inside of main, but I think it's fine for the time being to have. And it's just going to say if the error is not equal to nil. And for now, I'm just going to actually print the error message. And we're going to os.exit with a status code of 1, which means that we had some sort of issue with the program. And this is, it's a really small helper function. But I have it here because later if we want to change how we handle these errors in the main function, we can. And to use it, we just come up here and just wrap everything that could error with must. And this root command.execute can actually error too. So we're going to go ahead and add this in here and just have 2 musts. So it just reads a little bit simpler for the time being. It's not something I would recommend for like a web application or something like that, but for what we're doing here, I think it's okay. Next, we need to look at how to create tasks and store them in our bucket. So before we jump into that, I do want to quickly cover something that we saw here. I did db.update here, and if you've never seen that, you're probably wondering what is this. I mentioned earlier that there are read and read-write transactions you can do on Bolt, and read-write ones you can only have one at a time, whereas read ones you can have many. So if we look down through here, this transaction section, db.update is a read-write. So this is the one that's limited to just one at a time. And then there's also a read-only transaction, which is a db.view. So you're going to see db.update and db.view are the two we're going to be using here, where db is a Bolt database connection. So those are the two that we're mostly going to be using. There are others like this batch, but we won't be using them here. So what we want to add now is a way to create tasks. And in doing this, we need to, let's just go ahead and add a function for it. We'll say create task, and it's going to take in a task, which is just a string. We could take in a task structure, but I don't see the point in it, given that the user is not going to know the key for it. This is something that we're going to generate. So rather than having them, figure that out, why don't we just go ahead and just take in the string here? And then what we're going to return is, let's return an integer or an error. So the int will be the ID for the newly created task. Otherwise, we're going to go ahead, or I say ID, it's going to be the key is what it's generally called in Bolt terms. And an error is going to be there if something went wrong. So we need to be able to return those. So inside of our code, I'm just going to put return 0 nil for the time being, and we'll come back and fix that up here in a bit. We're going to start by doing a db.update. So we're going to say error : equals db.update. And again, I'm going to name this tx. We want to write this code inside of our update closure that will open up the bucket we need, and we'll try to figure out what the next ID we should be using, and then use this task to store it in there. So we're going to say b is equal to the tx.bucket, and then we need to pass in the bucket name, which is the task bucket. And then once we have the bucket, we want to go ahead and create or figure out what the next ID is. Well, I told you before that Bolt has a way to sequentially generate IDs for us for any single bucket. So what we're going to do here is ID64, underscore is going to be b.next sequence is what it's called. And you can see here that this returns, it's either an unsigned int 64, yeah, that's what it is, unsigned int 64 and an error. I'm not catching the error here. That's very intentional. I'm not catching the error here because whenever you're inside of an update transaction, the only way an error can occur is if the transaction is closed or it's not a writable transaction. So if this was a view up here, or if the transaction got closed somehow, which shouldn't be possible since we're inside of this transaction. So since neither of those are things that are going to be happening, I'm just going to ignore the error for here. So now that we go on past this, we need to store this in the database or in the bucket. So we do b.put. So put is how you put something into a bucket. And if the key is already there, it should override it. Well, looking at this, you can see that our key and our value both need to be byte slices, but we have no way of turning this ID64 into a byte slice. We haven't really covered that yet. So how do we do that? Well, to do that, we're going to go ahead and add another function. We're going to call it I to B for integer to binary, and it's going to take in an integer, and it's going to return, or sorry, integer to byte. Byte slice is what this is standing for, not integer to binary. So it's going to take in an integer, and it's going to return this byte slice. And to do this, we're going to use the binary package. Let me go ahead and look it up for you. So in this, we're going to be using, so let me see if I can find anything useful. All right, so here are a couple of examples. We've got binary.littleEndian, and then once this first part here is a byte order. So it's something, you can see here it's an interface being described. Byte order it's something that if you go take a computer science class, you'll learn about. It's basically just the definition of the order of the bytes, which is the most significant bit, which is the least significant bit. So the best way to put this is if you have a binary number, say you have the binary number of 2, which is 1, 0. Essentially it's saying what's the order of that. Is it 1, 0 for 2, or is 2 supposed to be 0, 1? And this is especially important if you know all numbers are 8 bits. So here we've got 8 here. So what it's really asking is it something like this, or is it something like this? And as you can see, if you've got the wrong ordering, This could be very confusing if you could read numbers incorrectly. So the order we're going to use here is big endian. And the reason for that, I don't have any real preference. The primary reasoning for this is that I believe the way that big endian is sorted and the way that Bolt goes through the database and looks at all the keys, big endian will keep it so that all the oldest entries are the first ones we look at. So if we have IDs of 1, 2, 3, we'll look at those first, and then we'll move on to the higher ones. So we want to go ahead and create a byte slice. It's going to be a byte, and it's going to have a size of 8. This size I'm getting from, let me see if I can find I to B here. So there is an example I to B function here, and this is where all this code's really coming from. So you could actually just copy this if you wanted and come back here and paste it, and I'll just explain it then. So first we create the byte, and 8 bytes is, or the size of 8 is what they're using here. Apparently that's generally fine for what we're doing. The next thing here is the big binary.bigendian, which is our encoding type, and then we're put uint64, which means we're going to take a uint64 and we're going to put it into our byte slice. So this right here, we're casting the integer passed in into an int64, and then it gets turned into this byte, or it gets put into that byte slice, and then we return that byte slice. We're also going to want the reverse of this. It doesn't do us a whole lot of good to take our IDs, convert them into byte slices, and sort in the database if later when we go to read these tasks from our database, we have no way of taking the byte slice and turning it back into integers so that we can tell our CLI what integers it needs to delete stuff. So we're going to go ahead and write that now. And it's going to be func b2i, so byte slice to integer. It's going to take in a byte slice and return an integer. And this one's going to be much simpler. It's going to be return int. So we're just casting whatever results, we're casting whatever results we get, because binary.bigendian dot, I think it's uint64. Yeah. So if we just pass in the B here, this uint64 returns an unsigned integer 64. So you're probably wondering, why don't we get a different type back? Well, since we're doing put uint64, I want to use the exact same thing down here to make sure that it gets done correctly. Otherwise, we could have an issue. So those two should handle converting integers to byte slices and converting byte slices back to integers for our keys. So now that we have that, we can actually come up here and say ID is going to be, or we'll say key is going to be I to B int ID64. I think that's the way we need to do it. And you're probably also wondering here why we just didn't take it in 64 as an argument. You'll see that here in a second. That should make more sense at least then. And then finally, return b.put. So our key is the one we just created. Our value is going to be a byte slice of the task. So we want to go ahead and convert this task to a byte slice that we can put into the database. And that should be what we're doing there. So we're going to say if the error is not equal to nil. So if our update failed for some reason, we're going to return, let's return -1 and then the error. Otherwise, if everything was good, we want to return the ID and nil for the error. But we have a problem. We don't have the ID. The ID occurred inside of this closure, and we never got access to it. So how do we get that ID? Well, this is one of the upsides to using closures, is that we could actually say var ID int up here. Then inside of our closure, we can say ID equals int ID64. So we're going to take whatever sequence we get, and we're going to go ahead and store it in this ID variable that we can access once this closure is completed. And then here, we can just change this to use the ID. And that is why, not entirely why, but that's part of the reason why we're using an integer here instead of an int64, is that we're going to be returning an int instead of an int64, so it just makes more sense to go ahead and convert it to that type. All right, so I think that's everything for this create task function. The next thing we want to sort of look at is how to read from buckets. And there are two ways to do this. You can read individually, so if you have a key, you can look up that individual task or whatever that item is. And the second is iterating over all of the items in the database. So to do this, we're going to go ahead and just write the individual one first. And I don't think we actually use this in our code. let me think about it. So list is going to list all of them. We're going to need some way to delete individual ones, but we don't necessarily need a way to look at individual ones. So we could skip this. Yeah, I'm going to go ahead and skip this for now. I think it makes sense to skip it because we won't be using it. So instead, we're just going to look at how to look at all the tasks. So we're going to go ahead and say func all tasks. This is what I'm going to call it. And this is going to return a task slice or an error. Or it's going to return both technically, but we'll set one of these to nil depending on what the other is. So here we need the tasks, and this is going to be very similar to this create task. We're going to create this outside of our database connection so that we can go ahead and set this data from inside of our closure. And then at the end, we're going to hopefully return tasks nil. So now we need to check on errors. So we're going to say error : equals db.view. And this is the first time we've used view. We used update in the, this last function. This time we're just reading data so we can use view. And we're going to say this is a TX, a transaction. And we're going to go ahead and write this code. So first we need to open up or grab the bucket. So it's tx.bucket and it's task bucket. Next we need a cursor. I want to go over here and show you hopefully it's right here. That's nice. Okay, so iterating over keys. The way you do this is you get a cursor, and then with the cursor, it'll start on the very first item in the bucket, and we can continuously call next, which will grab the next item after that one. So it's kind of like a linked list if you've ever seen them. We're just iterating over that chain. This cursor is going to allow us to iterate over every single entry in the bucket, getting the key and the value for each single entry. So what we're going to do here is we're going to say cursor is going to be b.cursor. Then we're going to say for key value in the starting at c.first, which returns a key and a value. Then we're going to say as long as the key is not equal to nil. So if the key is nil, that means that we've run out of items in our database, and the key will be nil. You can't check to see if the value is nil, or you could, but you shouldn't check to see if the value is nil, because technically you can have a valid key that has nil stored in it. So because of that, you want to go ahead and make sure that you're only checking the keys, because those should never be nil. And then we're going to say key comma value is going to be c.next, so the next item on the cursor. All right, so for every key value pair, we want to add it to our tasks slice that we're returning. So we're going to say tasks equals append tasks, and then we're going to create a new task, and this is going to have a key, and this is where we want to convert that key to an integer. So we're going to call b to I with the key, and then we want the value, which is going to be the string version of the value that we have. And this string part, it's converting the byte slice into a string, which should copy it. I'm mentioning this strictly because one of the things that's mentioned in the docs over here for Bolt is that whenever you're using these byte slices that come back from this sort of thing, I don't remember which ones exactly, but basically you need to copy the data from the byte slice and copy it into something else because they're going to be reused. You don't want those byte slices to get overwritten with other data, and then whenever you go to use it, all that data was overwritten. So you need to make sure you copy it to a byte slice that you know that is not going to be used within here. I don't know if it's just, I don't remember exactly when it happens, but I definitely want to say that it's safe, generally speaking, to make sure you're either converting it into something else or you're decoding it into something else, doing something so you know that data is copied elsewhere. And you could even just use copy, I think it's destination source. So you could just go ahead and say, whatever you want to copy, you could take V here and copy it into some other slice. We just don't need to do that right now because this string conversion should handle that. All right, what else is there? We need to return something from inside of this closure. So we've got this whole closure here, but we aren't returning anything. So we want to return nil. There shouldn't be any errors in here. And I want to see what this error is. Errors declared and not used. Okay, that's easy. So if the error is not equal to nil, we're going to return nil comma error. Otherwise, we're returning the task list and nil. And I don't know if I've covered this in other videos, but a lot of times you'll see me write code like this when I could just return both. The main reason I do this is just because I've seen people write sloppy code where they don't really check the error. All they do is say, if this is not nil, move on. Assume there wasn't an error. So they aren't checking the error first. And as a result, I like to go ahead and make sure that that value, if it can be set to nil, is set to nil or some invalid value, so that it's very clear to the user if they're not checking errors that they should have checked that error. It wasn't a valid value being returned. Okay, with those two, I think we have enough to go ahead and test this. We need to delete tasks, but, well, let's just go ahead and write the delete tasks function, and then we'll come back. So delete task, we won't delete task singular. We're going to take in a key, which is an integer, and this will return an error if there is one, and this will delete the task. So I'm using delete to mark things as complete because, in my opinion, it's the simplest approach right now. If you want to do the bonus exercises that are, the bonus part of this exercise, you'll have to change this a bit. You'll still want a delete function more than likely, but you'll need to find some way to store some metadata about each task so you can tell if it's been completed or not. Okay, so delete tasks. What does this do? So this needs to be an update first off. A delete is considered a write because it's actually affecting data inside of the database. And what we're going to do here is first get the bucket. So we want tx.bucket, task bucket, and then we want to do return b.delete, I think it is. Yeah, you just pass in I to b with the key. So that should be, and actually since we're not doing anything else with the error, we can just return this. And that's the delete task function. Very, very simple. Okay, so we've got delete, listing all tasks, creating tasks. If we wanted to go ahead and start using these, all we have to do is go back to our command stuff over here, and we just need to start plugging it in. So we've already got main.go's initializing all the DB stuff. So if we come back to these commands, list, we're going to go ahead and say, I don't remember, what's the readme say is this is supposed to print out? You have the following tasks. So we're going to go ahead back to list, and I'm going to put this in here just so I have it. So first we want to go ahead and say all tasks. And what this returns a tasks or error. So we're going to go ahead and just do error.error, and we'll exit here when this happens. So basically, if we have some sort of error trying to get the task, we'll just say something went wrong, print out the error. I think that's fine. Otherwise, we're going to say if len of tasks is greater than 0, actually we'll save it equal to 0. So we'll say you have no tasks to complete. Why not take a vacation? And we'll put something like a little beach emoji here. And then here we're going to just return. There's no real reason to do anything else. We'll just go ahead and return. Otherwise, we're going to say you have the following tasks. And we'll say for I task in the range of tasks. And we want to print out every single task with a number. We could print out their keys as the number here, and that might make some things a little simpler, but I like to just keep it in an ordered list starting at 1, so that's what we're going to do. So we're going to do format.printf, and we'll do %d. Let me go, I think it's just a period is how we're doing it, and then %s, then a new line. So we want I plus 1 task.value. I think this is how it was in the README. That's why I'm kind of hesitating. And it looks like what it is there. So we're going through every task. This first part, the I, is the index. The second part's the actual value of the task. The actual task object. It's a structure, so we need to call .value to get the value from it. And what we're doing here is we're going to go ahead and say I plus 1. So our indexes here are 0 based, so we want this to start at 1, not at 0. So that's what we're doing here. And then the value, we're going to go ahead and You just print that out. So if all is working, we should be able to do go install, and then task list. And I have the following tasks. So my tasks are here because I created them earlier. I created them whenever I was setting a lot of this up, and I think showing you how the original binary worked, and I didn't delete them all. So if I want to delete them, I think it's task.db. You'll see here that says you have no tasks to complete. Why not take a vacation? So both of those use cases are working. So next is the add. We want some way to add a task to our task list. So we have here, this is the task, we get it out and we turn it into a string and we say that we added it, but let's go ahead and actually do that. So we're going to do db.create task, and I just want this. I was looking for the autocomplete, but I wasn't getting it. And we need to catch, I think this just returns an error. No, it returns an integer too. It returns the ID, but we aren't going to need that. So I'm just going to go ahead and leave that as an underscore. I kind of just wrote it into original code because a lot of times you need it for different things, but in this situation we don't. And then we're going to say if the error is not equal to nil, we'll say something went wrong. And we're gonna return. I probably should os.exit1 here, but I'm just gonna go ahead and return for the time being. And then the next part, added your task to the, or added blank to your task list. So I think that's all good. So let's go install. Walk the dog, we'll try that. And you see here that this is now in my task list. I can do task list and see it. So I can do task add, finish this super long video. And you'll see that that's there. So the last thing we need is the do command. We want to take the do command and we want to make it so that inside of here, whenever we go to mark a task as complete, that it deletes it from our database. And this is going to be the longest one by far. You can already see it's somewhat long because we're trying to parse all the arguments. So after we get all of the IDs parsed, the next part is to get all of the tasks. And this is going to seem weird. Why are we looking up all the tasks? But you'll see here in a second why we're doing it. So we're going to say tasks, comma error is equal to, or colon equals db.allTasks. And then we're going to say if the error is not equal to nil, something went wrong. And I don't think I actually need to call error.error. I think I can just pass error. I should be able to pass just error in there. It should look fine. I'm not actually sure why I was doing it for all these others. Just got on this weird kick where I was typing more than I needed to. So I'm gonna go ahead and delete that. Okay, so back to do. Something went wrong, return. Otherwise, we have this task slice, and it's got all of our tasks in it. And I'm looking this up because our keys in our database are not the same as the listings that we're using for our tasks. You'll see here that we've got 1 and 2. It's always 1 base, so it starts at 1, then increments 1 by 1. Well, our IDs are not, or our keys that are stored in the database are not the same as that. You can see here that if I did, we'll say ID equals %d, and then do task.key here at the end. I should say key equals. So if I go ahead and go install this, and then task list, did I mess this up? Not sure what's going on here. Why is it not printing out my tasks? Did something not build? Yep, that's the issue. So I'm just doing this to make sure this stops erroring when I'm building. Apparently go install was, oh, it actually was giving me an error. I was just ignoring it. You can tell I'm tired today. It's pretty late here right now. So anyway, you can see that we've got key 1, key 2, but those are because we got a brand new database. So if I were to delete some of these, delete this first one from my database, this would get renamed as 1, meanwhile the key would still be 2. So you can't see it now, but I'll show it to you here in a minute so you'll really start to understand this. So what we're going to be doing here is we're going to look up all the tasks, and then we're going to remap all the tasks to the IDs that the user provided. So basically we're going to take them, we're going to look them up in our database, and then we're going to map them. One's going to be whatever the first one is, two is going to be whatever the second one is, so that the user can just type task due 1, task due 2, that sort of thing without having to type really weird numbers. So we're going to iterate over all of the IDs. And as we iterate over all these, there's basically 2 checks we need to make for any ID. The first is that the ID is not 0, or less than 0. 0 or less is not valid because they're supposed to be 1-based IDs. So we're going to say if ID is less than or equal to 0. And then the second one is if the ID is greater than the length of tasks. And normally you would be doing if the ID is greater than or equal to the length of tasks. That means we're going to access an invalid index. But because it's 1-based, we know we're going to subtract 1 from it. So we can use greater than. And then inside of here, we're going to put print line invalid task number. And we'll just put that there, and we'll continue. So we're doing continue here because somebody might type task due 1, 2, 3, and 3 might be the invalid number. So we're just going to go ahead and process the other ones. So say we had say it was just a 100, and then we had 12. So if 12 is valid, we want to go ahead and get that one as well, but just skip the 100. And I don't think I actually put handling multiple numbers in the original description, but I'm just doing it because it's really not that much more work to make that work. All right, so what is next? We want to figure out what task we're working with. So task is going to be tasks ID minus 1. So I said the IDs are 1-based. We're going to subtract 1 to make it 0-based. Once we get the task, we can do error. Is there not? There's no errors, I don't think. Is going to be db.delete task. And here we're going to do task.key. And if you are looking up here, I do have error declared up here, but it's outside of this for loop. So technically I don't need to do this colon equals, but if I do it, it's just going to, it's going to be a local one for just inside this for loop, which I think is fine for right now. So I'm going to go ahead and just let that happen. There are some downsides to doing this at times, but for what we're doing right now, this is not an issue. We're going to say if the error is not equal to nil, print f failed to mark %d as complete. So I just want to go ahead and note that we didn't get to print, or we didn't get to mark this specific ID is completed. Not that it was an invalid task number, just that something went wrong trying to delete it, and here's what the error was. So we're going to do ID, and then we're going to go ahead and do whatever the error was here. Else, we want to go ahead and say the task was successfully marked as complete. I'm going to copy all of this because a lot of it is very similar. So that's why I'm going to go ahead and copy. So marked blank as completed, and then there's just not an error message, and we don't need the error here. And I think that's it. We can go ahead and delete this print line IDs part. That should be all of this. So we're taking the arguments that are coming in. We're going over every single argument, parsing it as an integer. Then we're getting all of our tasks, and we're using all of these tasks to make sure that we can take a number like 1, 2, 3, a 1-based number, and use it to reference some specific task in the order that they're stored in our database. And this works because when we call all tasks, it always iterates over our database in the same order. So as long as we haven't deleted anything, it'll be fine. And that is something that I will mention here in a bit. If you type task due 1, and then later you type task due 2, what you do for 2 is going to be different because your original number 1 spot got deleted, or marked as completed. So that is something that is kind of a shortcoming of what we're building, but You could do things like use the actual keys to mark things as completed if you want. So let's make sure this all works. We'll do task do 1. And here I wanted to show you where 1 is not the same as the key. So if we do task do 2, you'll see that this does not work. We'll do show demo. So now we've got show demos number 2. Number 1 is finish the super long video. So if I do task do 1, then task list, you'll see here that this got moved up a 1 again. So, every time you want to mark a task as complete, one of the things that's a downside to us basing these numbers always on 1-based indexes is that you need to list the tasks to make sure you get the right one. But aside from that, I think this works pretty well. Okay, so that's it for this exercise. If you have any questions or you want to, talk about the bonus stuff or really anything like that, feel free to reach out. But otherwise, I hope you enjoyed the exercise.